is going to be another example. So let's draw our circuit once more. This one is going to be different, but it's going to be interesting because I'm going to solve it with a new method that you haven't saw yet. So my circuit this time going to have, well, a power source, of course. Then we're going to have resistance, why not? And then we're going to have another resistance. And then here we're going to have something. Okay. Down here I'm going to have a resistance. And down here again we're going to have another resistance. Okay, then down here at the very bottom we're going to have this, which is gonna tell me that the current is gonna flow this way. Okay, and then here we're gonna have another resistance all the way down here, and then from here at the very top I'm gonna go down. We're gonna have another resistance, and then all the way down here and all the way back to the source. So basically this one is going to be my power source, E, and this one is going to be my resistor 1, R1, my R2, my R3, my R4, my R5, my R6, gonna find this is gonna be A, this is gonna be B, gonna be plus, minus, so these will be VAB. I'm gonna hold this I of I3. And I is gonna be this one here. This is I. Okay. So the problem this time is saying for the circuit above, we know E equal to 12 volts, Ri equal to I ohm, I3 equal to 5 amps. Find VAB, this, and the current I. So this current here. Okay, so the very first thing that you gotta notice is that the resistances R4, R5, and R6 are connected as a triangle. It may not look like a triangle, but it is a triangle. So this is just a triangle. R4, R5, and R6. 4, 5, 6, 4, 5, 6. This is a triangle. So I can actually, well, in this case, since it's a bit of a mess, I can solve it by using something that is called the superposition of effects. So the superposition of effects. What is the superposition of effects? Well, the superposition of effects is a method that basically consists in drawing a different circuit, taking into account only a few things, solving that circuit, and draw another circuit, taking into account other things, and then superimpose one on top of the other, those two effects that I got from analyzing this circuit with taking into account only one thing at the very beginning and only another thing then, and then superimposing those two effects, I'm gonna get the real answer. So this is like the key idea. I know it may sound a little bit weird, but when I'm gonna be solving it and you're gonna see me solving it, it's not gonna be real. It's not gonna be weird at all. In this case, I'm basically gonna draw another circuit, which is just this one, but in which I'm gonna take into account only the generator E. So the generator E is gonna be the one that I'm going to consider, and I'm gonna open the circuit here. I'm not gonna be considering this one. I'm just going to consider this one. Okay, so I'm just gonna consider E, and I'm not gonna consider this, which is fine because I'm gonna consider this later, and then impose those effects. Okay, so I'm just gonna draw it back very quick. So if I consider only that, I will basically get this all the way down here, and here I will get this resistance. Here would be like this, and here I will have nothing. Here still the same resistance, and then the resistance down here, and then this, and here, as I said, nothing. And then on the very top we'll have this one as resistance, and then all the way back here. So these will still be my I, but I'm gonna call it my I first, and then the next one I'm gonna call it I second, and then I'm gonna superimpose them and I'll find I, but later, much later. And I'm gonna say, okay, hold on a second, this is still gonna be my E, still gonna be my R1, it's still gonna be my R2, still gonna be my point A, it's still gonna be my point B, still gonna have a difference of potential of those two ends, which I'm gonna go VAB first, and this is still gonna be my R3, my R4, my R5, and this one is gonna be my R6, just like before, but I just opened the circuit here, not considering this. Well, if I do that, I can say, okay, R1 and R2 are in series, okay, so basically I can consider them as R series, which is just R1 plus R2. So in this case will be 3 ohm. And then I can say, okay, so I first will be 0 ampere. And in this case, I will have VAB first equal to E over 2. So VAB first will be 12 over 2, which is 6 over 1. So basically VAB, this will be 6 volt. Okay. So now I'm just gonna consider where I3 is gonna act up as a generator, and the current is gonna be basically gonna go between the R series and R3. Okay, so if I do that and I draw it back, I'm gonna have, well, no longer E, so just this, and I will have R1. This will still be my R1, this will still be my R2, point A, and here here I will have this, here I will have this resistance, and at the top I will have this resistance, and then this resistance again. And here I'm gonna have the I this time, the I3. I called it I3 before, so it's still gonna be I3. And here I'm gonna have my resistance. Okay. So basically just like before, and it's still gonna be my R1, R2, my point A, my point B, plus, minus, this is VAB second, we'll call it second, so R3, R4, R5, R6, and we got this one is going to be my current, so flowing. So basically I'm still going to say, okay, this is I, but second this time. Okay, so in this case I'm gonna say, okay, my R series is actually gonna be R4 plus R5, because those two are in series. So we would have R4 plus R5, which is 9 ohms. So I2 in this case will be I3 times, so this one generator here, times, well, R series over R series plus this guy here, R6. So what do we get from this? Well, we're basically gonna get 3 ampere. So VAB second, it's gonna be negative VR1 plus VR2, gonna be negative I3 over 2 times R1 plus R2, which is just going to be, well, negative 5 over 2 times R1 plus R2, which is 3. So it's going to be negative 15 over 2. 15 over 2 will be actually 7.5. So this would actually be negative 7.5 volts. And we're almost done, because right now all we have left is just to find I and the real I and the real VAB. So we're gonna use the superposition of effects. So I is going to be I1, I first, plus I second. So in this case, I just going to be 0 plus 3. So I is just 3 amperes, of course. Never forget to add the unit. And VAB, the real VAB, in this case gonna be just like V first AB plus V second AB. So VAB is actually gonna be 6 plus negative 7.5. So VAB is going to be 6 minus negative 7.5. So VAB is going to be negative 1.5 volts. So there we go. We found both the difference of potential between AB and I, the current I that the problem was asking us to find. So that's pretty much it. And this is the superposition of effects. You consider just this generator without considering this generator, and then you consider this other generator without considering this generator, like this and like this, and then you sum up you use the superposition of effects, so you basically sum up the effects and you get the results. That's pretty much it.